Here we're going to look at the paraboloid. The paraboloid is what we call a three-dimensional parabola, and the math is a little more tricky, so we can consider this one of our spicy options. We're going to use a program that can graph 3D equations. I'm going to go and put in a new equation, and this is a z equals. Now the z is the height. We've got a three-dimensional graph here. If I point it in this direction, you can kind of see the arrows being the the traditional x-axis here and the y-axis here, but those two axes become our basically the floor, and the height, the z, is given by a function of both x and y. So we're kind of coming up off the paper. So I'm going to put in my equation 0.017. Before, my equation was y is 0.017 x squared, but this time it's going to be that the height is 0.017 multiplied by the combination of x squared plus y squared, and that's what this looks like. If you can kind of see it as I rotate it, it's like a parabolic bowl, and we're going to build this parabolic bowl by putting in cardboard supports at regular intervals down the middle. I know that the equation of that down the central axis here, aligned with this axis, is simply z equals 0.017 y squared. But I'm going to write my equation in a slightly different form. I want to know what the equation is. First of all, here at the very edge, this is y equals 30. This is 30 centimeters from the middle, and there's going to be a similar shaped support around every wall. So there's going to be another one over here, for example, and these supports are going to be symmetrical with the other direction too. And there's going to be another support here at 15 centimeters from the center. So I'm going to build it up with actually 5 of these supports. There's going to be one right down the middle, which is going to be our typical, I don't know, it's going to be our equation that we came up with, 0.017 multiplied by the x squared minus 15.3. Okay, so this is what we're looking for. Let's go back and look at some of the math that goes with that. So let me get rid of that title. We're going to call this looking at a section through a paraboloid, and I'm going to write the equation that we had out. It is z equals 0.017 multiplied by x squared plus y squared, and then I'm going to put in minus the 15.3 that we had to bring that down. That brings it down so that it's 15.3 centimeters below the z-axis. In this case is where the bottom of my parabola goes, and I want to kind of look at how this behaves at, let's keep in line with what we said on the grapher. We said we're going to put in y values, so we'll set y equals 30, and we'll look at what the equation is there, and we'll have y equals 15, and we'll look what the equation is there as well. Okay, so let's plug these in and see what we get. Z equals 0.017 x squared plus 30 squared minus 15.3. So z equals 0.017. Distribute that in, I get times x squared. Now then, 0.017 multiplied by 30 squared is 900 minus my 15.3. Okay, z equals 0.017 x squared. Don't forget that 0.017 times 900 is 15.3, and I'm going to subtract 15.3. So at y equals 30, my parabola looks like this. It's the same shape, it's just raised up 15.3 centimeters from the central one. It's kind of good to know. Let's have a look at this one. Z equals 0.017 x squared plus 15 squared minus 15.3. Z equals, distribute straight away, 0.017 x squared plus 0.017 times 15 squared. Let's look at Desmos. Let's use it to figure it out. Here it is. I did it once before for a dry run, so there it already is. 0.017 times 15 squared is 3.825. Then I'm going to subtract my 15.3. You can see if I go back to Desmos, kind of done it already, but minus 15.3, and it's negative 11.475. X squared minus 11.475. So you can see I've got these three equations. My original one was simply 0.017 x squared minus 15.3. I have at 15 centimeters out 0.017 x squared minus 11.475, and at 30 centimeters out 0.017 x squared on its own. So these are the equations that determine the supports that I'm going to build to make my parabolic bowl and put in straight flat supports underneath the parabola, cut out this shape from the top, fill in the top with mylar coated cardstock, and that's how I'm going to build my parabolic reflector.